Welcome back to our Quest AI series where we discuss getting started or expanding on AI projects. With me once again, I have Johann, our chief data scientist, here to answer some questions that I've had. Hey, Johann.
Right. Hey, how are you doing?
Good. How are you?
Good. I'm chilly in Florida.
Yes.
But other than that, I'm very good.
One of our chilly days in South Florida that we don't have many often, but
that's right. We'll take it.
Yes.
So what do you have for me?
First question I've got for you, my new friend Michelle from LinkedIn, she's asked, hey, Jessica, we are a B2C company in the manufacturing, retail, and logistics space. I saw your Q&A video and I was wondering what your take would be on the use cases around the generative video that's been making its rounds this week.
All right. So she's talking about this. Let me quickly bring it up. So it's Sora, S-O-R-A. And I'm going to go on this other screen so I can share with you what she's talking about, because it is very impressive. I looked at it, and just from the start, it was like, okay, I've seen some generative video before. This is just totally different. I mean, it's amazing. There's still a couple of small little things. You see when she's walking, you can kind of see her feet are sliding. So it's not like a firm step. But I mean, look at the reflection in the water.
Yeah. How are they able to even convey that? I mean, that's impressive.
And then look at the style. This is like an old style. This looks very much like gaming. So a lot of the training, I think, that went into this is probably going to be gaming type video. And then they have art museums.
I love this. So realistic.
Yeah. So I'm going to get stuck on this for a second, because I think this might tie into what she was asking about. What's the practical implementation for these things? So
my question in this, I guess, they are a manufacturing, logistics, and retail company. So how would this solve their business problem?
That's a great question, because they're not a movie studio. And everybody that I heard was complaining and saying, this is going to replace actors and movies, all kinds of stuff. And I'm like, I think we need to think a little bigger picture. So if you think how people learn, right? If you're a kid, you don't learn by somebody talking to you about stuff, right? You learn by doing. So there's this whole concept in intelligence, and I'm talking about human intelligence for a second. We build intelligence by learning from our environment. And if you look at companies like Boston Dynamics, with their robot that they have, the new one, Atlas, that looks like a human. Tesla has one that looks like a humanoid.
Right.
What I think those companies have right now is perhaps not something that's going to solve a problem very well at this point in time. But what they have is a framework to learn, just like a human does. So think about when you were a kid and your mom said, don't touch the hot stove. You might hear it and you're like, and you touch it once and you don't touch it again, because you learn. And that's called reinforcement learning. So in AI, that's one of the areas that, there's a lot of research that's been going on just around reinforcement learning, being able to have an agent that learns from the environment. And I think when you look at these videos, what it's doing, it's introducing us into a world where we're starting to enable learning to happen outside of language. Language is just a symbol. If you think about, like, I'm not the native English speaker, right? So when I dream, I have to think back, what language did I dream in? And I honestly can't tell you if it's Afrikaans, English, or pick Latin. I don't know. Because it's very symbolic, and actually symbolic or symbolism is one of the areas of AI as well that's getting studied a lot. But the point is that with video, it's not just a picture. You know how they say a picture's worth 1,000 words? Imagine a video, how much it's even more worth. And that one video that I stopped on with a guy was walking on a treadmill. So think about what the video or what the model is doing there. It's able to identify that it's a person walking and mimic the mechanics of that walking, right? So the bend of the knee, the stride, all of that. I'm willing to bet that there's no physics engine. There's no math that was used to go and teach the model how a human walks. It was by observing that it learned. So that brings kind of like full circle back to what you were saying, in manufacturing, retail, and what was the other?
Logistics. Yeah.
Logistics.
Yeah.
So for companies right now, there's probably not an immediate use case. I don't see, unless they're doing video and stuff like that. However, what I think it's enabling longer term is to learn from observing. And let's think about manufacturing for a second. I had a project a couple of years ago that we had to do where we had video cameras filming a person doing specific things at their desk, or not their desk, like a workstation in a manufacturing plant. And we had to analyze when they move their arms and how long it takes and count how many times they do it and all kinds of stuff. But really what we wanted to know is how efficient they were and if there's a more efficient way to kind of structure their work environment. Now, think about if you could train these models that's able to learn from observing without teaching them that moving the arm like this is the most efficient. We don't know that. Maybe there's a more efficient way to do it. And that's what you want the algorithms to learn. If you think about Go and chess and all these games, right? When IBM, Microsoft, Google, when they structured those AI systems to play against humans, there's different ways to do it. You can teach it all the moves in the world, but it's just too much. It's too much data. Or you can let it learn. And when IBM Watson years ago competed against, I think it was Ken Jennings, you tried to teach it every single fact there is. When Google Brain played Go, I think it was like 4 or 5 years ago now, what they did is they actually had the AI learn by playing. Nobody taught it the rules. And that is the beauty of what I see with this generative AI is that being able to learn by observing, being able to simulate, what we saw are beautiful videos and stuff, but think about if you created videos of amoeba interacting or cells like cancer cells reacting to a new compound. Those are things that you can now start to train AI to observe and learn. You can basically, instead of a person sitting and mathematically trying to figure out the formulas, you can have the AI learn that for you and then try and explain it back to you as a human. So I think we're still a bit far away from that. But if you ask me where we're going with it, those are the use cases I see that's going to be the most beneficial, most impactful in the future.
I'm very excited to see what it's all in store for. It sounds really cool.
Yes.
All right. So I have another question for you. This is actually from Jason, who's one of our partners. It was a client question. So he actually asked me, so he said, a client is busy with their digital transformation process, moving everything to the cloud. And I was saying, well, actually, we have a few of our folks working on that project. So this is going to be for a few clients. And he said, so their question is, as part of their digital transformation strategy, they are moving all of their unstructured data into a data lake. However, we keep hearing that we really need to think about data lakehouses. So what is that and why would they need it?
All right, that's a good question. So let's quickly do a recap. If you're looking at digital transformation these days and you're looking at moving your data to a central location, that's not necessarily the best approach anymore. A couple of years ago, people would say, yeah, just store everything in blob storage, whatever. But like a data lakehouse basically merges the flexibility that you have with data lakes and then the governance and performance that you get with things like a data warehouse. If you think Databricks, I don't know if you're familiar with Databricks, they have a data lake. I would say Snowflake probably would qualify as a data lakehouse. You have Apache that's got a couple of projects. I think Iceberg and I don't know if it's Houdini or something like that. And then you move on and you have like a data mesh, which is not really a database. It's an approach. And it's instead of you having a central location where you store all your data, you basically have a process where you have your data stored wherever it needs to store. But you have a layer that abstracts from where it's stored so you can query all of those together. It's somewhat different from federated databases. There's some similarities, and I'll talk about that in a second. And then, of course, NoSQL databases. Yeah, I mean, that's something that's, I would say, been around probably for the last 10, 15 years.
Okay. So really quick, I have a question. I've heard a lot from clients looking for NoSQL experience. So what would you say the difference between SQL Server, which is for structured data, and the NoSQL experience?
So when you look at NoSQL, right, in the name NoSQL, they're trying to make it as obvious as possible that we're not trying to be a structured database like SQL Server with columns and indexes and things like that. So when you think about MongoDB, you have Cassandra, you have DynamoDB. So those are all databases that basically gives you the ability to have semi-structured or unstructured data. Now, semi-structured data, if you think structured data is like a spreadsheet, you have columns. Semi-structured is like XML or JSON, which has like indentation. Kind of HTML would also probably qualify as that, but now I'll get people arguing with me a bit, but it gives you like a certain structure. But the point is JSON, those are semi-structured. And then you have unstructured, which is like language. This is, we see a lot of that now with language models and stuff. The difference really is that you can't necessarily have the same relationship stored in a database as easily, in a structured database, as easily as you have it in a JSON or a XML structure. So that's why these databases the NoSQL databases have very specific ways of storing it. Now, it actually, a lot of these databases kind of changed as well, where you have what they call multimodal databases. And what they do is they support different types of storage. So when you think about the columns that I talked about for like a SQL database, Oracle, those, for relational databases, what if I have documents, like a JSON document that I want to store or XML document? I want to store the whole full document, like a Wikipedia page, for instance, right? Or what if I have a graph database and I want to store that? Or if I have key value pairs, that's also a NoSQL database, but we call them multimodal because one database can store unstructured data, structured data, a graph database. I mean, it can store different structures in one database, which as a developer is awesome because now you only have one database you have to deal with. So I think it's important to understand those kind of databases and what's the use for it. So back to the original question that that Jason's client had, should they be thinking about lakehouses? My answer would be, it depends on what is your strategy. So if I don't think we help them with the digital transformation strategy, but if we were to consult and tell them, what it is that we think they should be doing, we would look at a couple of factors. One is we would look at what's the business use cases that they mostly deal with, right? Are they looking at reporting? Are they looking at building applications where they have the need for real-time streaming? Like in that case, they'll use something like Kafka. Kafka is one of the streaming platforms from Apache, I think. You also have Amazon Kinesis and a bunch of others as well. If they don't need that because those are expensive, then do they need to store the data for a period of time before they're going to start looking at it? Then Lakehouse, maybe blob storage, those are all good options. Or do they need to have their data in such a way that it is something that they can access very quickly and transform very quickly? Then Snowflake is like an awesome technology for that, where you can kind of store it without bothering with schemas and then inform schemas later. It also depends on the data. One of our other clients, they have a lot of video and image data, right? And where do you store that? Well, that's going to be S3 on Amazon, just buckets, or it's going to be blob storage on Azure, and then Google. I think Google call it cloud storage. I'm not a big expert on the Google technologies there. So anyway, the whole purpose of explaining all of that is that there's many different ways to store your data. And it depends on what's the use case, and it depends on what's the type of data that you store. That determines where you want to store the data. Also, what's the urgency? Storage it's pretty cheap these days. So if you just want to store your data to analyze further down a year from now, 2 years from now, I would go for the cheapest storage that I know is going to be easy to, build my ETL or whatever processes. And that is what S3, blob storage, and all those things are for. Was that too much?
No, I think that'll be good. I'm sending this back to Jason. So,
all right, good.
All right, Johann, thank you so much, you guys. And make sure you tune in next week. Get us over your questions, and we will see you then.